I am sharing. I had a lot of issues today with Teams, so if you don't see um, my screen refreshed on like, the new slides and all, let me know so I can actually address that. Okay, I needed to, and not only me, actually other people that I had uh, online meetings had some. I don't know what happened today, but hopefully you can see my first slide. I'm gonna flip, and you tell me if you don't see it. I'll try to fix it. So welcome. This is the 49th meeting. Anyone new here?
Yeah,
Uh,
hey, I'm new.
okay,
I am
hey,
new too.
welcome. Yeah, I'm super happy to have you. Uh, I'll I'll talk about in a moment. I'll talk about what we do here. I'll just present the agenda. And then we'll talk about what we do and all. So we're gonna have welcome slides, few housekeeping things related to what we present and sponsorship and all of that. Then some CPP quiz. You'll see what it is in a second, and then a single Walletfox slide. Uh, I'll talk about Walletfox in a second. And I have three items, two small items and one kind of a bigger one. Uh, the first two uh, things that they are completely generic, but I see it when I review code, and it gives me kind of inspire me, gives me ideas about like what kind of topics I can bring up for the meetup. So so that's basically the agenda. Hopefully, uh, it's about an hour 15 that we cover everything. Um, if you're a new member, welcome. We used to have a smaller group, so I used to people used to introduce themselves, but it's like the group got bigger and bigger, so it's harder. Um, but yeah, feel free to write your name and what you do in the chat and introduce yourself if you can. I don't know if everyone has access to the chat. Um, if you would like to speak and present, by all means, approach me and I'll be more than happy. It can be any topic related to C++, obviously, um, and can be any length. It could be 5 minutes, like lightning talk or more. If you know someone that would be interested in presenting, also let me know. Um, so I'm bringing people uh, to present from time to time. Amir Kirsch was uh, last month. So yeah, so there's so many things you can present, things that you read, blogs, books, and just your daily work if you're using C++. I have a mixture of things that I prepare. Some of them are very basic. Some of them are kind of more advanced. It depends on my mood. I think today there's like at least 70% are kind of basic to intermediate, and then the Pimpl would be a bit more advanced at some point. Um, so this is sponsored by Qualcomm, the wireless R&D software, which I'm part of, and specifically thank you for Charles Bergen that sponsored that event. He's paying like department is paying for the meetup fees. So again, thank you. I appreciate that. We have a Discord server and a Dropbox. So Discord server is basically I'm not actually dealing with Slack. I don't know why I'm having that, but I do announce on the Discord, and people sometimes ask questions. So if you want to access, just send me a request via Meetup, and I can send you a Discord invite. Uh, Uploading my recording to YouTube channel. You can browse the recent sessions that are uploaded. And I have a Twitter handle for the San Diego C Meetup. This is the handle. This is the handle, and I also have my own handle. I'm managing both of them. You can follow them. Uh, when I done with the meetup, I'll post the meetup link for the recording and some summary uh, on Martin's blog post. It's pretty generic, just what we did and similar. It's short with a link to the recording. So that's the housekeeping that I mentioned. Any questions? I don't see the chat. So if you have anything, feel free to just shout. Okay. So we start with the CPP quiz. So for this, what I'm going to do is I'm going to start about. So I have 4. Let's start with 2. I don't know if I have enough time for all 4. Worst case, we can do it next week. So I'm going to switch to my browser. Give me a sec. And this is kind of a fun thing. I pick the CPP quiz in a way that I think this can be useful for us. Okay. It's coming up. Share. Okay. Do you see it? It's big enough. Hopefully you see it.
Yep, looks good.
I can see it.
Okay, awesome. So CPP quiz, you can have the app, by the way. There is also an app. It's a very nice website that has a bunch of these small riddles. So this is the first one, 188. CPP standard 17. What is the output? And the options, so if you're new to this, the options, there are 4 options. Either there is an output guaranteed, doesn't compile, unspecified, or limitation defined, or undefined.
Undefined.
Undefined. I don't remember. Okay, let's start with undefined. And the person that actually said undefined would need to explain. It also explained, but do you want to explain why undefined? I don't remember. I went through that a couple of
I
weeks
think
ago.
the string literal is probably be placed in our segment.
Mm-hmm.
And you cannot cast away the comps.
Yeah. Yeah. This is a read-only rewriting. This is a bad idea. Don't do it at home. Okay. Next one. That was easy. Was fast. Maybe we will do the whole 4. To see. Okay. 28 is the next one. Same deal. 4 possible options. Just pick one. Okay, this is either have a guaranteed output or there are compile errors, or I don't think there is a compile error here. I think it's gonna compile. And we can start doing it together. Like you can shout the letters if you think there is an output. Okay, what happens here with A, with 2 A's? What happens here? We construct 2 objects there. Everyone agree on that?
Yeah, we should be calling the constructor twice, right?
Okay, so let's call the constructor twice, which is A. Okay, next. We iterating, there is a range for loop, auto X. What happens here?
That's a copy.
It's a copy. Okay, what is copy? This is letter B, right?
BC.
Okay, someone says BC. Why C, by the way? Because we're calling
Member function.
we're calling a member function. And then another B. Why another B?
There are 2 of them.
2 of them, exactly. That's it's a very simple, and there is an explanation what happens if, so the idea here, the kind of the takeaway is that if you're writing AutoX, this makes a copy, and it shows here how to make it without just taking a reference in order to avoid the copy constructor, which prints a B. Okay, it's you know what? Let's do another one. Let's do 3 today, and then we'll go to the next item. Uh, 2 to 1. My machine is super slow today. Yeah, I'm accepting guesses. Okay, so
1, 1,
what?
1.
1, 1, 1. Why?
See that I equal y actually changed the reference from x to y. So I guess we, oh, actually we get 1, 2, 2. Sorry.
1, 2, 2.
Yeah.
1 to 2.
Yeah.
Okay, let's try it. It's not 1 to 2.
Did we change the c.I equals y? Is that changing the actual reference as opposed to the value?
So I'll give you a hint. You can rebind the reference. Once you bind the reference, it is done. You can rebind the reference.
Okay, so it should be 2, 2, 2 then.
2 to 2. Okay, let's try 2 to 2. Sorry, my machine is so slow. I don't even know why. Okay, so since we can't rebind the reference, once we assigned the number 2, it's 2. Okay, so x basically we alias, right? So x becomes 2. It's just an alias, right? Y is 2. We didn't change y, and see that I, again, it's 2. So I'm gonna piggyback on this question. What do you think about this class? What is the issue with classes or structs? When I say structs and classes, it's the same thing. Just the access specifier is different, the default one. What is the issue? Why sometimes people advocate against having a reference and a data member, which is the reference? What is the issue with such class or struct? Think about the special members, data function members. There is a slight issue with these functions. What do you think? Just guess.
There's something weird about the ownership not being like encapsulated within the actual structure or class, right?
Yeah, that's one thing. Ownership is one thing. You depend, but beside ownership is an issue. I agree. Beside ownership, what happens with copying or assignment operator? To be exact, assignment operator. What happens here?
It's deleted, right?
Sorry?
It's deleted. I mean, they are deleted. The copy constructor and copy.
Yeah, but
assignment.
if you want, okay, true. But if you want to add one, what's the issue with references? You can't rebind it, right? So you can't really rebind reference to another. Once it's set, you can't rebind it. So the assignment operator, if you want to have an assignment operator, it's kind of an issue to have a good one because you can't really rebind once the object is pointing to something. You cannot just point it to something else, the reference that is. So that's one issue that people kind of sometimes advocate against having a reference. Just FYI, sometimes it's good. Instead of a pointer, a reference, you bind it to something and you can forget about it because it's always pointing to something. But just there's one caveat that you need to be aware of. Okay, so I'm gonna leave the fourth one to the next one so we can have the agenda. I can move forward with the agenda. Okay, so the next one. So every click is really long. Okay. What I'm going to do. So I'm sharing. Hopefully you can see the share. Okay. Do you see the share? Everything looks good?
I can see it.
Okay, perfect. Okay, Walletfox. I keep talking about Walletfox. The person behind it is Rosina. I don't know if I butcher her name, so I'm sorry about it. I wanna just mention she has a very nice ranges v3 booklet, kind of a tutorial, both on PDF, like you can have a soft copy or a printed one. I think shipped from Switzerland, if I'm not mistaken, or Germany. I'm sorry, I can't remember exactly from where. Somewhere in Europe, and there should be an updated one soon. So if you're looking for ranges v3 material, this is I think one of the best ones. So there is an updated version. I contacted a few weeks ago, and I think by the end of this month should be something that she would announce. So that's one thing. Go grab it if you want to take a look at the ranges v3. Okay, so this is one of so in the website there are all kinds of slides. I really like the way it's presented. So here's one thing that we can learn. P-apply and query. So query is a kind of a functional programming terminology. Let's take a look at P-apply first. So P-apply is a function that takes two parameters. One, there is an f and there is an x. It returns a function. So it's a function that returns a function. Okay, and the first one is basically should be a callable one because we're calling it here, and we capture whatever we need to capture, which is basically x, and we have one free parameter, so I can pass an argument to P-apply. It's really similar to what we had before with bind to first. So I'm taking x, binding it to the first parameter. So this argument I bind it to the first, and then I have y that I can use later. I have an example in the next slide, so don't worry if it looks a bit confusing. But just to show you that in C++, in modern C++, we can have function returns functions very, very easily and nicely. This is a lambda that returns another lambda. It's pretty nice. The next one is, as I mentioned, is a query function. It's basically a way for us to have the same idea, but in stages. So I'm passing a function. So this is, sorry, my cursor is so slow. It's pretty amazing. Auto F, and I'm returning a function. The function takes x. When I pass x, I'm getting another function that I can pass y. And eventually, when I pass y, I can invoke f with X and Y. And this equal sign, making sure that I'm capturing what I need to capture. So I'm capturing F, I'm capturing X, and then I'm invoking F and XY. Obviously, there are other languages that they have similar syntax, not identical, but very similar. Python has something like partial that I'm aware of that has kind of a very similar to the Ppply kind of a partial functions. It has lambda, and Rust has kind of same idea where you can have lambda and use it. So other languages they have the same idea. So here's an example how you can use it. Obviously, it's a very simple example that I created, but you can extrapolate it to something that you can use. So I have this max function that's just called max, stud max of X and Y. It can be anything. Just imagine anything that you can think of. Papply and carry are exactly the same one as we saw in the previous slide. And so here's Papply. I'm taking max and biting 3 as an X, which is gonna be here. So this returns a function. Since it returns a function, I can basically call it with 4, and I'm gonna get the results. Here it's a bit different. Curring is, by the way, there is a very good book about C++ and functional programming, which I forgot the name of the author. It's from Manning. If someone remember the name of Ivan Kuchik, I think. I don't know. If someone remember the name, please stop me and we can just name the person. So there is a very good book if you're looking at C++, kind of modern C++, functional programming with a bit of ranges. This book from Manning publication is really good one. It's a really good one. Okay, so and it talks about carrying as well. So here's the idea. So carry max. I'm getting a function back. Then I can invoke 3, getting another function. Invoke 4, and eventually the final result happens. So there is a Godbolt link. You can download the slides later and play with it. Stop me if you have any questions. Okay, so the next item is something that I've seen during kind of a code review. There was a question. So this is a very generic few slides, but kind of based on a question during a code review. Why I cannot in place back this specific syntax? And I'll talk about what this specific syntax. There was some assumption that if in place back works with this syntax, it should work with another syntax. And I thought it's worth kind of mentioning that as an item here. So first of all, I keep kind of mentioning Arthur Adwire blog post about in place back versus pushback. Not super related to this issue, or not issue, but kind of what I'm trying to demonstrate. But it's a very good short blog post that explains what are the differences, when to use in place back, when to use pushback. Makes it much cleaner to understand like when to use each. So I just Google for that. It's a very good blog post. Okay, so let's take a look at some examples. So what is commented out means that it's not compiling. Okay, and I tried, I did my best to explain why it's not compiling. So just ask me if it's not clear, but I'll go over that. So I have a vector of foo, and foo it's an aggregate. It has an integer I, and I push back of 1. It's an aggregate. I can do that, no issues. So all of these are pushback, and then I have an in place back, which I'll explain in a second. But if I try to have a pushback of 1, I don't have a constructor. So without a constructor, I'm unable to do that. Okay, the first one worked because it's an aggregate. Okay, what about the other one? The other one is actually saying I have a foo that has a constructor, and I'm passing 1 to the constructor. This I don't have a constructor. It's a simple aggregate without a constructor that I defined. So I cannot do that. The next one would work because I'm actually using the feature of foo being an aggregate, so I can do that. And the last one, in place back, again, I cannot do that because I don't like in place back. Basically, just taking a constructor and creating it in place, but I don't have a constructor that takes an integer, so I cannot use it. So let's see what happens when I actually do create a constructor. And it's a very simple constructor. Does nothing, just to illustrate. This works. Uniform initialization still works with this constructor. 1, passing 1, that's fine. It's implicit constructor. I can take an integer, create a constructor, and pass it to pushback. It's fine. If I put explicit, it's not going to work. Okay, foo of 1 now works because I have a constructor. It works. It's still an aggregate. And then in place back. Now, in place back works here. Why? Because there is a constructor. So in place back is a variadic template. There is a constructor that takes 1, so we can basically create foo, pass it 1, and now it works. So the idea here is that if you have a constructor that takes an integer, I can in place back with the integer. It works very well. So there are some, yeah.
Sorry to interrupt. Are you sure this foo is an aggregate type?
I might be wrong. If it's not an aggregate, it's just a uniform initialization.
Yeah, I think that the first pushback is going to use the
uniform initialization.
Yeah.
Yeah, and the fourth one is probably also. I might have a mistake here because I copy pasted from the previous slide. So I usually test it with type traits. I might be wrong. I can't remember the rules from the top of my head. I usually check it with type traits, but I might be wrong. And this is just if it's not an aggregate, it's uniform initialization that happens here. Okay, so now let's talk about unique pointer. Let's say instead of vector, I have a unique pointer. So the assumption was that unique pointer behaves the same. So foo has a constructor that takes an int. The fact that we have it inside unique pointer should not matter, but it does matter. So let's see what happens here. So we have a foo inside a unique pointer, inside a vector. I cannot push back 1. There is no any conversion that takes 1 and turns it into unique pointer. Okay, how about new foo of 1? No, why? The constructor of unique pointer is explicit. There is no implicit conversion to do that. So I cannot do that. I can make unique. R value moved, all good. I can use it with make unique. Again, in place back of 1, it's not going to work. There is no unique pointer that takes 1, that takes an integer, right? The fact that we have foo inside doesn't mean anything. The unique pointer is what we're actually trying to in place. How about new of foo 1? This actually works. Sorry about the typo. So in place back is going to explicitly call the constructor with foo star. No real value here. I would maybe stick to make unique, but maybe that's also fine. There is no loss here.
It's not exception safe.
Yes, Yeah, I agree. Yeah, it's not exception safe. Because this is why make unique is better here. If it fails, at least it cleans up. Now the last one works. It's not surprising. The surprising part is why I cannot in place back one. You cannot in place back one because unique pointer, the fact that it has foo doesn't mean that it would bypass the creation of make unique pointer and pass in integer. You need to be explicit about, okay, I'm going to place back a unique pointer that actually has foo, and I'm passing the argument to the constructor of foo. So this would work. So the takeaway is that while we could do it, like we could in place back one, where we have this foo of with the constructor of int that works. It's not the same where you have a unique pointer. Unique pointer is another. That's the class that you in placing. It's not foo that you're in placing. You're actually in placing a unique pointer that just happened to have foo. So you need to play by the rules and first create the pointer, create the unique pointer that has a foo pointer inside, and then pass the argument to the constructor that is for the type that is contained inside the unique pointer. So that's basically the takeaway. There was kind of a surprising from the kind of a third party saying, okay, why I cannot in place back one? I can do it without unique pointer. Why unique pointer actually changed the rules here? This is basically why this whole thing behaved this way. Okay, so the next item talks about stutai in C++. I find stutai and structure binding a very useful thing that can help us write kind of a shorter code, maybe kind of a more concise and easy to understand. So I usually find it kind of a niche in the sense that people don't know enough about stutai. That is, it's still useful even with C++17 with structure binding. I'll show why. I reach out to structure binding as much as possible when I need, but stutai does have few good use when you need it. So let's start with C++17. Let's actually start with structure binding. So I have two lines of code here. One is stud vector. I'm using ctat just to demonstrate how to use ctat here. This is an integer. This is a vector that you know. It's a template class. It's a class template. This is class template argument deduction, deducing int, and I'm just creating a vector here. Okay, there is this syntax where you have an auto something equal and then the actual type. It's kind of common recently, so I'm just demonstrating that. The next line is calling equal range of 2, just to provide a range of 2 and 2. So it's going to be a begin and end. And instead of kind of traditional, oh, I'm getting an iterator or a pair that points to 2 iterators, I'm actually using a feature from C++17 to kind of structure binding, deconstruct this tuple or pair into 2 variables. I don't need to define B and E, it's defined here. Okay, this is important because in stutai it looks a bit different. I actually really like structured binding because I can do things like that. I can take S and deconstruct it into the different elements. Same idea with tuples, pairs, all of that would behave very similar. So it's very useful. Just make a note when you need to do things like that. It's very handy in range for loops where you maybe iterating something that returns a pair or a tuple. Let's say you iterate over a map. It's really nice. Instead of taking the iterate and then do that first, that second, you deconstruct it and use it immediately with good names instead of first and second, which doesn't tell you exactly what you're actually deconstructing. So it's a very useful feature. Okay. So before we had 17, we used stutai to do something similar. So here's the same code, but instead of using Cppquiz 17, I'm actually using stutai that you can have since day one. I think it was introduced. So same deal. It's a vector of int. This is still a Cppquiz 17 syntax, and then I have a const iterator. Just I don't need anything but const iterator. In order to make it generic, instead of using stud vector, I'm actually decal type v that gives me the stud vector. So just to demonstrate a generic way to write code. And then b and e, I'm not initializing them. And then stutai. So in stutai, I do need to have the both b and e defined before. There is no other way for me to have it defined in place, just like structure binding. That's kind of the caveat, but it's still convenient if you cannot use structure binding. The other thing that is very convenient is the way to ignore something. So stud ignore is something that you can use not only here in this context, but in other contexts. It's kind of swallow the value. And actually don't need to define E now that I'm seeing that. I just need B. So so this is a typo from kind of a copy paste from the previous slide that I had. It's a very useful. Stud ignore is very useful. It's also useful if you need to ignore maybe a return value from a function that is maybe a no discard and similar. So it's a very useful tiny utility class that I think is defined in tuple, if I'm not mistaken. Yeah, I cannot deconstruct one. I don't know if it's visible enough. I tried to demonstrate reconstruct S with tie. I cannot do that. It's failing. So that's one caveat with tie. I cannot deconstruct that. But tie has actually other very useful usage that you should definitely use in various scenarios. So one of the nice thing that you can do, that's one way to look at it, is to let's say I have an operator less than. That can be const even no except. So, and I have these members, and I want to compare them in order. So N, S, and D. Instead of having that spelled out with an if, else, and all, stutai does the work for me, which is really nice. So I can actually have these two structured, and then I can just have S1 less than S2, and this tie less than this tie does the whole heavy lifting for me. And it's also useful if you need to set it into a specific ordered specific container, for example, set. So how do I order S? So I order S by having this less than. So the default compare function is less than. It looks at, do we have an operator less than? I do have an operator less than, and I shift the heavy lifting into stutai, less than stutai, and it's really easy to kind of deal with less than this way. So it's a very handy small utility. I find it that a lot of people, they don't know this nice trick with stutai, and I always like to kind of promote that usage. It's really nice trick. Any question before we go into the last section of the session today? Okay. Pointer to implementation, or Pimpl. Very horrible name, but I'm just the messenger here. And like, who knows about this design pattern? Just curious.
I know.
Ming, you know, okay. Do you use it?
Yeah, a lot.
You use it a lot. Okay. Can you without like sharing specifics, just the generic context, like where do you use it? I also, by the way, really like this pattern.
I think there are two ways to look at it. First one is like Scott Myers mentions in his effective C++. This is a technique to decouple the dependency between different compilation units.
Yeah.
The second one would be to implement a design pattern. I believe it's called bridge.
Yes, right.
So that you have the control layer separated out from the implementation layer.
Yeah. Yeah, I'll mention that. Thanks for bringing it up. Bridge is one thing that is related to pointer to implementation. I remember reading about it, I think, in one of Herbstadter Guru of the Week, which I'm going to mention. But it is a design pattern that shows up in few. I don't think it was in the classic design pattern, the Gang of Four. I would say that I don't remember seeing it. I'm 99% sure that it's not part of the classic design pattern, but it is heavily used in a lot of places. I really like the ABI stability that it can provide when I need to. I don't want the user to know about my members that I'm hiding behind this pointer to implementation. So thanks Ming for sharing that with us. So let's talk about kind of I'm having this opportunity to promote one book that I think is wonderful. Supervised software design by Klaus. So Klaus is an author and a speaker, very known one. I had the pleasure to attend at least one presentation, one talk from him during CPP Con 2022. And he's a great speaker, so I highly recommend you to go online and search for his talks. He explained very well things. So his book, he writes like he speaks very well. So this is his latest book that I highly recommend. If you are from Qualcomm, you have access to this book online with a single sign access. So you can definitely use it. This is a great perk from Qualcomm, and you can either have the soft copy or hard copy uh, purchased by from Amazon or any other store. So this is one thing that I recommend, and it does have pointer to implementation explained with the kind of tied to what Ming said about bridge. So it explained the differences. So there is a nice paragraph explaining the differences between them, and it's a great chapter if you have the opportunity to take that. Okay, so one way to see or to name this pattern is Pimpl pointer to implementation, but you can also see another terminology, compiler firewall. So compiler firewall is basically another, I think Herb Sutter was the first person that I've seen this coming from him as the kind of the the terminology. I'll explain why compiler firewall, but this is from CPP reference. And it's explained here that in both Pimpl and factory method is another design pattern. I think this actually comes from the Gang of Four. I think factory method is part of the Gang of Four. It removes the compile time dependency between implementation and the users of the class interface. Factory makes method creates a hidden dependency on the V table. We don't have a V table in the pure Pimpl approach. There is no such thing. It might be a byproduct if you do use inheritance. I'll explain that in a second. So they are kind of similar, but Pimpl it doesn't necessarily have a V table if you don't need one. If you don't need this virtual polymorphism approach. Okay, what else? Okay, so one of the things, kind of piggyback on that, one of the things that you can see here as part of the CPP reference is this propagate const. I always want to have this small detour about why do we have this propagate const. So propagate const. Long story short, I basically see there might be more ways to see it, but I see top level const, which is basically a shallow, and there is also kind of a deep const. So if you think about pointers, you can have const on two elements of the pointer. One is the pointer itself and what you're pointing to. So the top level one is the pointer itself. What you're pointing is the deep one. So let's take a look at what propagate const provide us as kind of an additional trick or additional feature that we can use in order to make things kind of a more const correct. I don't know, is anyone using propagate const? It's from experimental, but I don't know if anyone is using it. I've seen that in books a few years back. Anyone using it that can share some experience if it's useful enough? If not, I'll explain. Okay, it's pretty simple. Here's a snippet of code. You have struct x has 2G. One is they're overloaded. One is const with a printout, I'm const, and one is non-const. The idea, if you are kind of new to C++ and this whole const function is not really clear, the idea is very, very simple. So x as a type has two functions. It's overloaded. I can overload on const. I'm talking about const function, not the return value, but const function. If I have an instance of x that is const and I'm invoking g in compile time, this is a compile time, it's not dynamic dispatching or anything. In compile time, there will be a binding, in this case, binding to a const function. If I have an instance of x that I'm holding and it's not const at the point of the call site, so I'm gonna call the non-const one. Okay, so that's basically, in a nutshell, what happens. So in this case, I have a struct that has this propagate const that takes unique pointer of x. And this is the endpoint, and it has f. Again, f is overloaded with const, and it's just called g. So you can imagine that whether it's a const or not is gonna be important. Okay, so y is defined here. I have an instance of y I call f. Okay, so f is a non-const. Remember what I told you. There's gonna be a binding in compile time to a const or non-const. Depends on what I have, what I implemented. So it says f non-const and it calls g. This, since I'm a non-const, m pointer x is non-const. There is no const here. Okay, so I'm calling G, which is going to be a non-const. So this is why we have here. Now I have a const y, cy, and I'm calling f. The first one is pretty obvious. I have a const of f, which is const. The second one is not that obvious. Okay, so I'm calling f again through const. So f is const, and then I'm calling g, and I'm getting the const one. Okay, so that the interesting part is why this is happening. Like I could show you the other syntax where I don't have propagate const. Okay, so it's the same one. I have a unique pointer of x, and you can see that I actually took the same code and I changed it to have just unique pointer of x. So yeah, m pointer here is const, but x is not const. X itself is not const, so I'm not calling g, that is the const one in this case. But here, oh sorry, here x itself also, the const is propagated to the x, which sits inside unique pointer, and I'm actually invoking g, which, if you think about it, this is super useful tool. If you have unique pointers and you want to propagate the const further, this is basically a great usage of propagate const in order to make sure that the functions that I'm invoking through unique pointer, they are also constant.
Hey, Goki,
Again,
so
yes.
guess you can achieve the same effect by using const cast, correct?
Yes. Yeah, I could do that. Like TPP reference could do that, but I think this is probably more elegant.
Okay, got it.
Yeah. I think the confusing part that people might stare at this and say, okay, in here, m pointer x itself is const. So if m pointer x is const, why g would not be const? And this is, I think, this is the confusing part. At least when I first encountered this technique, it's just not propagated. So maybe we could see the arrow. So the arrow, the operator arrow of unique pointer might have an overload with const and non-const, and in this case, the non-const probably is invoked. I'm just guessing here, unless you have a propagate const, which basically pick the const one. That's how I basically see that. So, okay, so that was just a detour. Let's go back to pointer to implementation. So I'm going to piggyback on Herbcider compiler firewall Guru of the Week 100 and 101. They're actually kind of two blog posts that he posted some time back, a few years ago, and he explained about the various use cases where you want to use compiler firewall. And I'll basically just reflect on what he was explaining with some of my personal opinion, and then we can converge about what is the best, not best, but what is the common approach that people should use, and people that like me, that if you want to share from your experience, like what works well for you, please go ahead and stop me. Okay, so the idea is that when you have a class and you include this class, you have data members. You have data members and you have functions. All of that is basically affect the size, the layout of what you see. You as including that and using this class. Overload resolution also kicks in. Remember that overload resolution is taking place before overload resolution takes place before we actually looking at access specifier. So you might take a look at when you do overload resolution, you don't look at access specifier. People think that I do overload resolution only on let's say public, because that's what I see. No, public versus private kicks in after overload resolution. So if your best match is private and you don't have access to private, you're actually not gonna be able to compile. So all of that contributing to ABI stability, and I'm changing one member. I need to recompile. Sometimes I need to if it's a class that or file that be included in many compilation units, I need to go recompile the entire word. So I believe meaning that this is another useful trait that you probably enjoy when you use pointer to implementation, that you don't need to recompile the word if you change something in the implementation. So I'll call the implementation, that's basically where all the beef happens. And then there is the class that is kind of the front-facing class that we use to host the pointer to implementation. I also going to mention something that Herbstadter is advocating a lot, especially in the non-virtual interface. I'll talk about it in a second. When you have a class that has both a public API and virtual functions, this class has contract to two different entities. One entity is the client that are using the public API. You have a contract, so you need this is basically the contract between the public API and anyone using it. But there is another contract. If you have a virtual functions, there is another contract, and this contract is with your derived classes. Okay, so what does it mean contract? Contract is like you change something, who is gonna get impact? So if you don't have virtual functions and you just have a public API, you change something, your clients might be impacted by that. If you have a function that is both public and it's a virtual function and you change something, you actually need to deal with two clients. One is the public API clients, and another one is whoever is deriving from you. You also need to explain what happened to the derived class. So there is a method, like a pattern that Herbstadter called it the non-virtual interface, where you actually separate these two concerns into two different entities. I personally really like this approach because it really helps to separate concerns. Just bear this in mind. Okay. Trade-offs. Alternative to the Pimpl idioms are in an implementation, basically the private members and the public members are members of the same class. So that's one alternative, not the best one. And pure abstract class, basically factory. Bridge is another kind of a way to look at it. You obtain a unique pointer to a lightweight abstract class, and then the implementation details is in the derived class. This is a pure, very classic kind of a factory pattern that you can use, and it's a polymorphic one. Any questions? Okay. Compilation firewall, I already explained that. I just mentioned that there are two CP preference mentioning two core guidelines that I recommend you to read. It's part of the overall core guidelines that you can take a look at. For me, the important part of compilation firewall is ABI, not exposing ABI changes to the user. So I can make my changes, change the class layout, the Pimpl class layout, without impacting the clients. It's a huge and obviously compilation if you just happen to include it in many compilation units. Okay, so the guru of the week is divided into few questions. What it is, what is the best way to express Cppquiz11, and then we'll see a nice idea of how we can actually express that in a more generic way. And there are 4 options that Herbstadter is presenting. How you actually implementing this pattern, and we'll go one by one. So one is putting all private data, not functions, into the Pimpl. So the Pimpl is the one that actually does the implementation itself. And then put all private members, including function, into Pimpl. Then put all private and protected members into Pimpl. We'll talk about protected members. Is it a good idea? And then put all private, non-virtual members, function, non-function, but private members and non-virtual functions into the Pimpl. Or put everything into Pimpl and just have everything just offload into the implementation. So what are the trade-offs? We'll talk about it. So what it is, it's a easy way not to recompile everything. I already explained about access resolution and overload. So it's just the same thing that I mentioned. So this is how it's going to look like. You have this struct Pimpl and then pointer to implementation, just opaque pointer. And this is something that I took from the page. All the hidden members are here inside the Pimpl, which is nested inside widget, and the public interface doesn't have the members. It's not part of the class itself. Okay. Should it be a raw pointer? We basically would like to have a unique pointer with a small caveat. So here's how things would look like. So I have a class Pimpl which is nested inside widget, and this is the header file. So you can see there is nothing here. There are more functions that might be here, but this is just kind of the bare minimum. And then the implementation file would have this class widget colon Pimpl because it's nested inside widget, and there is this either equal default or user defined. Obviously, equal default is better. And here I think make unique makes sense over the new Pimpl. I think this was pre-14, if I'm not mistaken. So why do we need the widget destructor, and why do we need to define it in the implementation file? Anyone? I think every developer that is using unique pointer and embedding it inside a class had at least one linker error that she or he was fighting. Anyone can guess what happened here? So the problem is that unique pointer, you can define, you can construct it without the full implementation of Pimpl, but the destructor, when the compiler is creating a destructor of widget and destructing Pimpl, the unique pointer, it needs the full definition of Pimpl in order to create the destructor, and we don't have it here. So what do we say? What we tell the compiler is, I'm just having declaration here for the destructor. The definition is in some other place. Definition is in the implementation. There is a full definition of Pimpl, and the destructor of pointer to implementation is happy. It doesn't. It's not the case with shared pointers. Shared pointer capture more information that is useful for destruction when you construct it. Not the case with unique pointer. So just FYI, if you have a unique pointer and you don't have the full implementation of what you actually capturing here, you'll have a linker error. how you fix it, you declare it, the destructor here, and define it. Equal default is enough just to satisfy the linker. Basically, that's what I'm saying here. Okay. So Pimpl is move friendly. There is one caveat here that this is why it's in red. Since I need to define a destructor, my own destructor, I'm actually disabling a lot of stuff. Move, even though it's move friendly, I'm disabling the move. So just be aware that you need to bring the move. When I say move, all like anything that you need to basically move in this case, because it's unique pointer, you need to bring it back. The move constructor and the move assignment. So just be aware that if you define your destructor, you're losing it. And I think I explained it like maybe a year or a couple of years ago. Okay, let's talk about the 4 options like quickly, because I want to focus on the best approach, because that kind of lack of time, and I just want to jump into the session that actually explain what is the best. So one option, and this is something that not me but Herb is ranking. So 6 out of 10. How good it is? 6 out of 10. The first option is all private data, not functions. So leave the function as is, private or not private. So that's one thing. The implementation of the visit class needs the Pimpl all the time to forward. That's true for a lot of options, not only for this option. So remember that. I still need to recompile the world when I add or remove any private member function, because the private data I'm moving, but if I change something that is still private, I still need to recompile the world. Yeah, it's true for any public as well, but if we focus on private members, it's applicable. So that's one option, not the best one according to Herb. Okay, all private members, 9 out of 10, and Sutter mentions that this is probably usually the usual practice today, to have all private members, function or not function, into Pimpl. And I think this is true. Most of the implementation that I'm seeing, that's what I see. The private section has only Pimpl. All the public ones are just forwarding to whatever the corresponding one. The problem, what Herb explain here, is there is some problem with if I call it the host, the top level class is actually also a polymorphic class. A polymorphic class, you can't really hide virtual functions. You can't really put it in the Pimpl because you need to override. So that's kind of an issue. You need to go and override it, and then sometimes you need to pass it to the Pimpl, have a back pointer to the host class in order to invoke the virtual function. So it's kind of complex when you have the top level one as a polymorphic one. I personally didn't have this use case ever, so all my pointer to implementation, the one that hosted the top level one, was not polymorphic. I don't know, Ming, did you have any need for polymorphic on the top level class?
No.
No, okay. That's what I thought. I never had this. So this is how it's going to look like. You have this base class, and the Pimpl is here, and somehow you need to address you need to override all the functions. So it's kind of clunky. And there is a compromise. You can also add the non-private functions into the implementation, would be used by the private one. So basically, you move more things like public one or protected one into the implementation. So you have it in the same scope, which is also kind of a compromise. Okay, 0 out of 10 have all private and protected members into implementation. So I'm going to focus only on the fact that what is protected members, and this is I don't remember if this is something that Herbsider had or me adding. I think I added this. I don't think there was a core guidelines mentioned in the blog post. So I kind of discouraging people to use protected, but there's always exceptions. Okay, but usually what I see is the protected is kind of a public in disguise, and this is if you look at C133, the core guidelines, C133, and actually Sizeof software design, that the book that I showed you from Klaus. I think this is page 257. It's not like there is a 2,500 pages. This is a typo. Don't be scared. There's not like too many pages. So 257 probably has a mention to this core guideline classes section 133. Don't use protected. Obviously, there's always corner cases. I didn't find one, or maybe kind of exceptions. I didn't find one yet, but there is always a kind of an exception to the rule. So don't use it. So this is basically 0 out of 10. For hierarchy access sake, you cannot or should not hide protected. So if you have protected, you can't really hide it in the Pimpl, because the whole idea of protected is someone is going to derive and want access to the protected. You want to grant access to a specific data member or function, so you can't hide it. So this is, I think this is why 0 out of 10. So the last one, the last option, actually it's not the last, the one before the last, is put everything, put all private, non-virtual members into the implementation. Kind of simple to do, and ideal solution. I think this is again the common part. Have all private. If you have virtual members, put non-virtual members into Pimpl. This is good because they're non-virtual, so no issues if someone wants to derive. You don't have issues overriding because it's non-virtual. Again, I personally used to have a clean non-polymorphic on the top level one, and kind of being done with that. Yeah, there is a mentioning about the back pointer. You can also add any public functions that the private needs one. If you need, there is always a way to pass a back pointer to the top level if you need to. Okay, 8 out of 10. Everything is passed to the Pimpl. You don't need a back pointer because everything is the same scope, the scope of the pointer to implementation. The drawback, the visible class is useless for inheritance. You can't really inherit because you actually forwarding everything. So you can't really inherit because it doesn't work. That's also kind of a common approach. I don't know why he added as 8 out of 10. So let's have a summary. Object-oriented principle has, as I mentioned, interface to the caller. This is the API. There is an interface to the derived class, which is either protected or the virtual functions. And then there is a private non-virtual data functions. So the private non-virtual data function is what you need to focus when you have the implementation. That's basically what you want to hide in the implementation one, and forward everything that you need into these functions, the non-virtual data functions, private one. The public one should be probably stable. Obviously, if you change it, you need to recompile everything. I mentioned the non-virtual interface that is part of the Cppquiz coding guideline. Cppquiz coding standard book. It's an old book, from, I would say 2003 or 2005, between these years. I think a lot of pages are still, it's 101 guidelines by Herb and Andre. I think it's still applicable to a lot of what we do today. Just to reiterate, private non-virtual data member is usually what you want to hide in the pointer to implementation, the implementation itself. So, which means that your API, the public API is stable. You don't need to recompile when you change it, because you don't need to change it. It's pretty stable. In case you need a back pointer, you can always use something like that. So this is basically, when I say back pointer, you have a function in the top level one that calls the impl and then arrow function. You pass this, and this would be used for invoking on the host. I call the host the top level one, and then the parameter. Yeah, you add another parameter to each hidden function. So your pointer to implement, if you need to pass a back pointer to your top level, each function in the impl would have basically a parameter. The first parameter would be the type of the top level one. I never used it. I don't know, Ming, if you needed a back pointer, I never used it. It was I kept it very simple in my case, so I didn't need to have any fancy back pointer, but it's there if you need to. There is a summary. I'm gonna focus here. So class, top level class versus the implementation. Your interface, your public interface to the caller would be in your class. Should be stable one. Interface to the derives. If you happen to have your class as the polymorphic one, and you have it protected, you need to put it in the class, not in the implementation. Private non-virtual members would stay in the impl, would actually move into impl. And there are some comparison to bridge and another handle body, which is another type of very similar to this one. Okay, so I'm just focusing on the pointer to implementation one, which is this one. So these are basically the guidelines. Just remember this. I think this is the way to go. The last couple slides just show how we can actually generalize the pointer to implementation. So imagine you have this class, a template. It's a class template that has a type name T, and this is where we host the impl type inside a unique pointer. This is basically the constructor of the top level one, passing a variadic template arguments. Remember, we have the destructor. The destructor itself would have either equal default, preferable equal default, because it's more modern. You don't need to have an empty one, and you can basically forward very simply with either overloading the arrow or the reference in order to forward that to the T type. This is basically how you would implement that. Instead of using a new unique pointer is encouraged here. Already explained about the destructor, and this is how you actually forward the calls to the impl. If you need to do just a simple forwarding to the impl one, that's the easiest thing to do. So remember that one. How do you gonna use it? So if I have a widget and I need to hide it behind a Pimpl, I would just use the impl class, and here I'm gonna implement everything that I need that's gonna be forwarded using the arrow operator and the ref one. So this is very handy if you need a pointer to implementation pattern. This is a nice, it kind of reduce the boilerplate code in order to just reuse something that is common to all your classes. So that's basically it. That's it. That is my last slide for today. Is there any questions or comments that people wanna bring up?
I think there is a design pattern which is related to the MVI technique. It's called template design pattern.
Yeah, template method, right?
Yeah, sorry.
Template method. Yeah. I personally, by the way, my personal opinion and personal preference, I really like the non-virtual interface. I actually asked. I met Herb Sader in person. It was 2009 or 2008. Just before CppCon was a thing. There was like between BoostCon and CppCon, there was a small scale conference in Seattle, and so I met Sader and said, "Hey Sader, Herb, what do you think about the NVI? Should we use it?" And again, it's kind of very close to the template method, and he actually said that this is something that should be considered seriously in a lot. Like it's not like 100% of the time you need to use it, but yeah, he said consider that. It's a good way to separate concerns between the API that the client sees and your contract to your derived classes. So you separate these concerns. It makes life very easy in terms of maintaining your class. If it needs to have a virtual, a polymorphic style, plus obviously it has public interface. It's really good to kind of separate these two. Okay. Okay. Thanks, everyone.
Thank you, Kobe.
Thanks, everyone. Have a good rest of your day. Have a good rest of your week.
Thank you so much.
Thank you.
Thanks.
Thanks.
Have a good one. Bye.